So, to get started here, my name is Parker Twin. Welcome, everybody. I'm on the board of directors with TACDA. And so, first, just to get the disclaimer, as we do every time, nothing in this presentation should be considered legal, medical, or financial advice. The opinions of the viewers and the presenter can differ considerably and do not necessarily reflect the opinions of TACDA. You should always do your own research and consult with professionals. In order to maintain the flow of the presentation, we kindly request that questions be held until the designated Q&A period. You're welcome to enter questions in the chat at any time, and they will be reviewed after the presentation. For this meeting, we'll be pausing for questions when indicated, in addition to the questions at the end. So, for today's presentation, this is essentially part two of the presentation. And in a nutshell, the title vanished. The nuclear radiation fallout protections. This is part two of this series with Sharon Packer. She is a nuclear biological chemical shelter design expert, as well as being on the TACDA board. So thank you so much, Sharon, for being here. And we are ready and willing to learn. So yeah, take it away. Everyone just post your questions in chat, and I will read those off as appropriate.
It's my pleasure to be here. This is the second part of our design series. The first part, we talked about blast shelters, and I will do a small review of what we did last month. And I'm just getting over a cold, so you'll have to forgive me for a lot of clearing of my throat. So the blast shelters that we were talking about last month, we have to prepare for EMP, for the thermal pulse, for the blast, for the radiation, and for war gases. And that's about the way they would come in series. We get the EMP first, and the thermal pulse is about the same time, and then the blast follows, and fallout will come for days and days afterwards, the most far-reaching, and then the war gases. And so fallout shelters are going to be a little simpler. We just have to worry about EMP, fallout, and war gases, because now the initial radiation, all of those difficult things that we talked about last time are not part of a fallout shelter. So as a review, we have to be less than 15 miles from the target to really be in that blast zone. If we're beyond 15 miles, then we can justify a fallout shelter. We have to have that structure independent of the upper structure. The thermal pulse, we have to deal with that in various ways. And I didn't talk much about that, but I can try to cover it in it as we go. The separate HVAC systems, because we can't have them connecting to the upper part of any other structure. Blast doors opening towards the blast, bare walls, and hardened plumbing and electrical systems. So we'll just review each of these things just slightly. So the direct effects of blast, the top is a 200 kiloton blast, and the bottom is a 1 megaton. And it's a little hard to read this, but this actually says 6.5 miles, and this says 11.2. And look at the overpressures. So in this area of 1 psi, we're not seeing total damage. We're seeing broken windows, cracked foundations, some a little more than others. But as we get closer to this area in the 5 psi range, and a lot of homes are burning, everything is totally destroyed, and in this as well. And then the 1 megaton clear out to 11.2 miles. And so I thought we probably won't see anything more than a 1 megaton blast. So I figured if we could get beyond that 50-mile mark, then we could maybe justify a fallout shelter if that's all we can put in. Of course, I prefer that we put in both blast fallout together, but if fallout is all we can do, then anything beyond that, we would most likely survive in that area. This is what that 1 to 2 psi can do. 1 psi, again, cracked foundation, broken windows. 2 psi, we're going to start seeing some damage. In that 2 to 5, the home is not going to survive. And notice how it's falling into this basement shelter. So if this were constructed so that the top is independent of the home, then that's not going to fall into your basement shelter. So this would be like they're sitting in a fallout shelter, and the home has failed, and it comes in on them. Higher blasts, of course, it can blow everything away, but of course the neighbor's house might blow into your basement as well. So we want to be very familiar with our primary targets and our secondary targets. So primary targets, if we're then within 15 miles of military bases, seaports, airports, command and control centers, large cities, then we're definitely in that target zone that would justify the blast shelter that we talked about. Secondary targets might not be quite as difficult to work with, but they may not require the nuclear blast that these others do, but we want to be aware too of secondary type targets, refineries and bridges and tunnels and railway stations. And so be aware of what's around you. Look at your targets and make note of them, and look on a map and see how close you are to those targets. So the independent upper structure that we talked about, do you remember how we talked about we have to put the rebar up into that basement shelter? It has to all be tied and turned. And so all of this will turn into the concrete ceiling on this structure. So we were talking about the independent structure. In this concrete structure, you see the rebar, how it turns, how it comes up and turns, and then it will overlap into the concrete that comes on the top. And then the home itself rides separately on top. Any structure, base, garage, home, whatever it is, would ride on top. And so they are tied together, but not so that it affects the ceiling of this shelter, the blast shelter. Where a fallout shelter, we don't have to have that so totally independent. But we talked about displacement and concussion. So in a 15 psi blast, that shelter can move with the earth 1.6 feet in a 15 psi and 2.3 feet in a 45 psi blast. So that's a lot of movement. And the relative displacement means that relative to the earth, it would move a couple of inches away from the earth while it's moving back and forth. This is movement of the earth and the shelter moving together. So are there any questions about this? Does anyone have a comment or question?
All right, I think we are good.
Okay. So we have to have a separate heating, cooling system in blast shelters, because any of the heating that we have in an above floor room is going to have the contaminated air. And as it comes down, we have to totally shut that off with gas tight shutoff valves. So this is an example of a gas tight shutoff valve. The conduit would come in with the bad air, and then we would shut that off totally with this. And I like the manual ones. We would shut that off so that it doesn't come in again into the system. And then we would be living independent of the HVAC during the threat time. Blast doors opening toward the blast. Now the inside of the shelter is here. Whoops, do that again. The outside of the shelter, he's opening the door to go outside of the shelter. And you see how this door rests against the wall? And so that's what carries the blast load, is the door resting against that wall. And it's filled with concrete so that it gives another 8 inches of shielding. And so in a fallout shelter, we don't have to be quite so concerned about doors going away from the wall, and they could be maybe internal to the frame here, where this one is external to the door frame. Bare walls. Now, do you see in this is a Swiss shelter, and the concrete walls, This is the conduit, the electrical system coming in through a piece of metal piping like, but everything is bare walls. There's no studs, there's no drywall, there's nothing on those walls that when it's hit and it moves that foot that it might be moving, it's not going to fly off the walls and hurt us. So in blast shelters, we have bare concrete walls. Hardened plumbing and electrical systems. So we like to suggest the dry toilets, but we can harden the plumbing systems. We can harden the pipes. We can make a hardened holding tank. But when you're moving 1.6 feet or even 2 feet in a 45 PSI, you've got a lot of give you have to give to that plumbing pipe and to the electrical wiring. That wire has to move or it's going to break. The plumbing has to move or the pipes are going to break. And the electrical as well. These these lights, they ride independent, and when that shelter is moving as much as the outside is moving, then that light has to be free to wobble a little bit. But anything that's tied against the ceiling in a blast shelter, any kind of a fixture up there could be dislodged and could cause damage, and then you don't have your lighting system. So in a fallout shelter, we're going to have a much simpler solution. So the only thing we worry about here is the EMP and the fallout and the war gases. And of course, that's plenty. Are there any questions now about the little review we just did?
I am not seeing any.
Okay, yeah, go forward. Okay, Paul did a good review of EMP a few months ago, but I just wanted to remind you, one nuclear detonation in the center of the country at 150 miles high can affect the entire continental United States and up into Canada. So you can see that this any place where line of sight to 200 miles, we're going to have EMP. And EMP causes an awful lot of damage. It comes in 3 parts: EMP1, EMP2, and E3. And that E1 comes in just nanoseconds. So it's very difficult to stop that E1. And it takes very technical engineers to do the hardening against that E1. It affects our computerized systems. Everything in our life now is computerized, and all of that could be affected by the EMP. Control systems, semiconductors. A lot of people think they could use MOV surge suppressors, but it just knocks holes in that MOV, so it won't stop it. The E2 is similar to lightning damage, and that takes milliseconds. And so it lasts maybe maybe up to a second. And then that E1 damage, it can damage equipment that's designed to protect us against the lightning strikes. So once that E1 comes, then it's difficult to protect against the E2 and the E3. The E3, that's long duration, up to 5 minutes. And it's damaging those high voltage power lines. It comes down through the stratosphere and it interacts with the atmosphere at about 25 miles high, knocks the electrons off of the atoms. Those electrons start spinning down the Earth's magnetic field lines, and they couple with all of these long voltage power lines, railway signaling systems, long communication cables, large DC-like currents, and they can cause fires. And you might remember we talked about the Carrington event and the fires that were caused in those telegraph stations. And that's a concern because we thought, well, maybe it could cause fires in homes too. But there are some comforting facts about those old telegraph wires versus our home systems. Those telegraph stations, they had long wires to different stations, and they were earth grounded. So you have, it comes back through the earth in a big loop So Earth became part of the return path. And so that massive loop area caused more of a problem in those stations. It flowed through those little telegraph instruments. It affected the relays, the electromagnets, the sounders, the switches, and it caused those small coils to get very hot and to burn. And there were a lot of things that were sparks that were flying. And so they think that in our homes with the shorter circuits, there's not going to have that much of a problem. And we hope that that's true. It could be, but we want to be very alert and keep fire extinguishers near our metering boxes and looking at any place where that EMP may have entered into heavy appliances where it might start a fire or had some arcing. There'd be possibly arcing through the receptacles in our homes. So we have to be very aware of it, but they think, and when I say they, there's experts and there's experts. And so some of them think that this is going to not be the fire problem in the homes that it would be in large commercial buildings, in big hospitals, places that have long lines versus the fairly short circuits that we have in our homes. So the transformers, of course, are affected by that. That DC current that goes through an AC line and an AC transformer, it's going to destroy that transformer. So transformers are gone, and we might not get our electrical back for months, maybe even years. Any questions? Now, I'm the last one to ask probably about EMP, but I could, if there has a question about EMP, I'd be happy to discuss it.
So third party, my name is JC. How you doing?
Good, thanks.
Good. So third party manufacturers of EMP protection for homes and vehicles, are you aware of any of those that are actually any good?
I'm not aware of any. I know they have a lot of claims, but the only people that I work with are the technical EMP protection companies that come in with their huge filters, and I don't know how much protection they actually give. They may do, but I'm not aware how much protection we can get. I do know that we made friends with Ron Chakotis years ago, and he was testing vehicles against EMP in simulations that the government had put up. And the vehicles, the later model vehicles, seemed to be surviving quite well. The early models that didn't have the computerized ignitions were surviving, and then the later models that had a lot of metal around their engines and just seemed to have a better protection. But those later models cars were surviving, and we talk all the time about possibly if the car should stop in an EMP on the freeway, wherever it is, that we could try taking the cables off of the battery system and then letting that discharge, maybe even touching them together after a minute or two and letting that discharge, and then putting them back on to see if it reset the computerized systems. And of course, some of them will be burned out, but it may reset that so that we can start the vehicle. But they had to restart a couple of them that way, and they started and ran just fine.
Huh. Interesting.
So our fallout shelters, as you've said, we want to be off grid if we can, keep that fallout shelter off grid, battery power, and a lot of people are bringing grid power into their shelters, but of course that introduces EMP. And if you have any appliances or anything in that fallout shelter, then they're going to be affected, where if you don't bring it in, it's a little better, but concrete shelters are not going to be, they're still going to be vulnerable to the EMP, where if you're in one of the steel pipe shelters, then you're fairly safe. But the DC lighting, I like those low voltage DC lights. I do use LED lights, but I've got a bunch of them that I keep in Faraday cages so I can change them out, because I don't expect that they'll survive, but they might, they're little. Make sure that any of your ventilation is a hand crank type. You want to be able to run that, everything you can, you've got to be able to run by hand, and to be sure to have some good fire prevention. And especially if this is a fallout shelter, because your home above may catch fire and burn, and you want to be able to put out any fires that you can. So you have to have a lot of fire extinguishers and be aware of where that might be. I like to, when we talked about it earlier, I suggested that we even close our blinds and our curtains, so that if we had lighter colored curtains, so that thermal pulse didn't cause fires inside. But we won't have the thermal pulse in fallout shelters, so that's a concern about the blast shelters. So the solar, again, I think that's really a good way to go, and I don't know any other solution. Hydro, we did a little bit of hydro on our area, but not very much, and that would be good as well. But still, controllers will be the same thing. So the radiation, and this is a review, and a lot of you know a lot about radiation, but let's go through a little review of it. It's the gamma radiation that we're concerned about, and that first 2 weeks is the time that we would have to worry about gamma radiation. Alphas and betas, they're going to be around for a long time. Their half-lives are very, very long. And so we can deal with those in other ways, and we can talk about that a little bit as we progress. But gamma radiation is the big concern. So it's the most far-reaching of all the weapons effects, and we can see it as an accumulation of dust and small particles. We often said, well, if you don't see any dust, then the radiation is very low. And so you might be in a very low radiation dose area. But if you're seeing it, if you're actually seeing the fallout, then you're in some fairly high radiation levels. And so, but even if you don't see it, doesn't mean it's not there. You've got to still take the same precautions, and hopefully you're having meters and dosimeters, whatever you're using to read those levels. So it's carried by the prevailing winds. The fallout is carried by, and this is a website that I often visit. I hope you can see it. It's in red. That it will show you the prevailing winds, and you can put a dot on the earth where you're concerned about. And when you get that dot, it will tell you how many degrees it is. So if it says it's around 270 degrees, and then 180 to 270, the 270 would be that the prevailing winds are going from west to east. 180 would be south to north, and 90 from east to west, and then north. Didn't spell that right, south. But it's a little hard. We often said, well, prevailing winds basically go from west to east. And so you can see in January, that's holding fairly good. It's holding fairly good west to east across the nation, and then it kind of starts up. But look what's happened in July. You know, it's very difficult to put your finger on those prevailing winds and know where they're going to be. And so that website, I visit that regularly, as often as I can. And my home is in southern Utah, and so the prevailing winds that I'd be concerned about are coming from the south at Nellis Air Force Base. I'm about 150 miles away. And so it's going to tell me what direction those winds are coming from, and also the velocity. And so usually those winds are either coming west to east, which would miss me because we're north of Nellis, or they're coming west from the south going towards the northeast. And so then that hits into us quite badly. And they're coming at about 15 miles an hour. So if I'm 150 miles away, then that prevailing wind is going to carry that fallout in at about 15 miles an hour, which would be in about 10 hours, I'd be seeing that heavier fallout. This is what it looks like, that website. And you can see the winds here. They're showing in all these various places, but it'll show you, I've marked a little place there that's where I live, but this one doesn't show very good on the winds, but the website does. It'll show you the winds actually moving. So it's a really neat website. So look at it, become familiar with it, and figure out where those prevailing winds are coming from your targets, from primary and secondary targets. And then even if you're not in the blast zone, you know what kind of fallout levels that you might be looking for. So we're going to reduce that fallout by time, distance, and shielding. And so we'll talk about the time aspect. I told you the time that it takes for it to get to my place is about 10 hours. So this 7-10 rule says after 7 hours, I've lost 1/10 of that 1,000 rads per hour. So I'm only getting 100 rads per hour. After 2 days, or about 49 hours, I'm getting 1/10 of that, which is just 10 rads per hour. And 2 weeks, I'm getting 1 rad per hour because it's 1/10 of that. So we call it the 7-10 rule because we take 7 hours and divide and multiply it by 7 and multiply it by 7. That this would be the 7 times 7 would be 49 hours, and then we turn into days. But that's basically what it is if we multiply by 7 and divide by 10. Any questions on that 7-10 rule? I probably didn't explain it really good, but
No, not on the 7-10 rule. There's something on a separate topic though.
Okay. All right. And so this is what that looks like. You see how quickly that decays in 7 hours. It's way down in 7 hours, and then over 14, and then continuing to 2 weeks. And so the big drop is in that first 7 hours, but it's not going to be enough. So this shows you a map of the 500 kiloton, 200, 500, and 1 megaton. And I'll see if I can read some of those numbers to you. This 1 megaton, I don't know if you can read this, but you can see radiation levels clear out to 210 miles. And this area, 500 rads per hour, 50 rads per hour, 5 rads per hour, half a rad per hour. So you can see that you're still getting radiation clear out to 210 miles. And so we need to be protecting ourselves for that first 2 weeks. And a 500 kiloton, it's less, and 200 less, but who says they're going to use one megaton? But you know, they might use several of these or a combination of these, so that we really need to have those meters in our shelters so that we can read them. And a meter has to be calibrated. And some of you have meters, some make sure that you're reading correctly. We kind of think in rads per hour, and that so many rads per hour on our penalty charts. But if you're looking at sieverts and those things, you have to change that number so that you can read it in correctly. So the shielding aspect, any questions about distance? The further it is, of course, the less it's going to be. And this is true in our shelters too. If we have a fallout shelter in the basement and we have a 2-story house, that fallout is going to be on the roof of that 2-story home. And so we're not going to get so much radiation at a 2-story home as we would in a 1-story home, because the distance factor makes is a real blessing to us the further we are away.
For a question, we have Daniel asking, are these distances of fallout patterns reflective of an air burst or a ground burst?
I think that I think I have 2. Maybe I didn't put the ground burst on there, but the ground burst effect on a 500, the 1 psi level goes out to almost 6 miles on a 500 kiloton. And on an airburst, it goes out to about almost 9 miles on the 500 kiloton. So it doesn't go as far on the ground burst. The air burst is designed to make that blast level go further, but the ground burst, between 6 and 8, and that's why I kind of look at 15 miles and think, well, we maybe could get by with the fallout shelter at 15 miles. So protection factors. A protection factor of 2 provides protection from half the radiation as measured from outside the shelter. So if we have a 1 inch of steel, we're going to keep half of the radiation from getting inside the shelter. 3 inches of concrete, that would give half the radiation. 4 inches of dirt, 7 inches of water. Now, steel is very expensive, so to get a bunch of steel in there is not going to be real practical, but that's kind of, you can see that it's more than just distance, it's mass. The heavier it is, the better attenuation. So a PF2 provides protection from half that amount. So if we had outside measurement of 10 rads and inside measurement of 5 rads, that's a protection factor of 2. So when we're looking at soil, that doubles every time. 4 inches of soil is a protection factor of 2. 8 inches will double it. Another 4 inches doubles that. Another 4 inches doubles it. And so if you get 10 doublings of anything, whether it's dirt or concrete or steel, if you get 10 doublings, you get a protection factor of just over 1,000. And so 10 doublings of steel would be 10 inches of steel would give you a PF of about 1,000 or more. 30 inches of concrete would be about 10 levels of 3 inches, and that would give you a protection factor of 1,000. Is there any question on that?
Doesn't believe so.
Okay, so the 10 halvings is the secret. I would, they talk about a protection factor of 500. Well, 4 inches more gives you 1,000. So why not go 4 more inches? And if there's a rain out, you could double the radiation level. And so that rain, when it gets in and comes from the fallout is coming down from the stratosphere and into the troposphere where our weathering is, and then we get rain, and it's kind of like seeding the clouds anyway. The fallout is like seeding. Then we'll often see rain, and that pulls it out quicker than what it would have been. It has a long decay time in the air, where the time issue comes in play again, because if we bring it out too fast, then it's hot and we're going to get more radiation. So in St. George here where I live, we were getting radiation levels that were fairly high from the Nevada test site during the 60s. New York had a rainout. They had more fallout, more radiation, higher radiation level at that particular day than we did because of the rain. So you want to make it get as much shielding overhead as you possibly can. Now, if you're putting 40 inches of dirt or 30 inches of concrete or a combination of the two on your fallout shelter, you're going to have some massive walls. You're going to have 12-inch walls on that fallout shelter. You're going to have a good strong floor and massive footings. And so it's not a whole lot different than doing a blast shelter when you have that much protection. But the fallout, you're going to have to protect against that fallout just the same way from blast as well as from just the fallout. I think we went over that. This, again, is that airburst. Let's see, we were looking at the 5 psi, 10, 20, so forth. So again, if we're out at that 11.2 range, then we're not going to have the issue. So let's look at low fallout risk areas. If we have a protection factor of 5, say we have a couple of maybe just a small dirt shelter, you're going to get 600 rads with a protection factor of 5. we look at the penalty chart. We want to stay within this 150 rad area in 1 week. We've got to get up into that 150 area. Anything over that, and we're going to have medical care that we need. And at 600, we're not going to survive. Most everyone would die 100%. So if we're going to get in the 150 range, we have to get in the PF 20 and more, because we could get 150 to 300, and we don't want to get 300 because that would put us into more of a risk area. But if we can keep it below 150, then that would be a safer area. I don't want 150. I don't even want 10. But if we have to get 150, then we don't have to be totally panicked. But you can see that the PF of 500, for instance, with 9 layers of dirt cover, you only get 6R. And that's, to me, you know, you can live with 6R. I don't want, like I said, 150, but that we can be having a shelter with a PF of 40 or 60 and still within this, if we're in that low level. So let's look back here. That low level would be like in this level, in that 1 to 2 PSI level. But if we're closer in, or if those prevailing winds come faster, or if there's a rain out, then we can get into the higher levels. So the medium fallout. So if we're in the medium, we have to have more of a maybe in the PF of a 60 to get in that around that 150 total rads. And so this isn't per hour, this is the total rads that we're picking up for the week. And so you might be getting 50 in the first 7 hours, but then it decays very quickly and you may not pick up more than the other 50 in the rest of that week. But again, 150 is all we want. If we're going to have some medical care, well, there's not any available. And most everybody dies at 450, you know, half of them at 450. And if this were 600, you're going to expect most everyone to die. So you've got to be very careful and get the proper shielding overhead. So this is a 1 megaton, and this goes out, like I said, to the 210 miles. And so at 140 miles, you're still at a half rad per hour. At 30 miles, you're 5 rads per hour. At 90 miles. And 50 miles, look at the 50 rads per hour. Well, 50 rads per hour, that's a lot of radiation. And so we want to make sure that we're getting that down. 50 rads per hour, you know, that first hour, we're going to pick up 50 of this. So we want to make sure that I would suggest that you have nothing less than 100, a PF of 100, but I'd much prefer 500 or 1,000.
For these diagrams, Sharon, the ones you were showing with the fallout spread, David's asking where you can find that diagram and the other ones with the various air bursts.
I had these in my old FEMA books, the NAPB 90. You may be familiar with NAPB 90. They may still be available in libraries. And so that's where I got mine.
Sharon, do you think that might be listed in the nuclear war survival book?
It might, it's certainly talked about and listed, but I don't know that they would have a chart like this.
Okay.
I haven't seen charts like that, but they have that nuclear war survival skills. Was that Kearney's?
Uh-huh.
He may have something more. I was thinking you were talking about the effects of nuclear weapons.
Oh.
Gladstone.
Okay.
Gladstone, that is really the Bible for all of the information. Gladstone is
I'll
just
put the
book.
I'll put the link in the chat just in case.
Okay. So let's talk a little bit about expedient sheltering. You know, maybe we haven't been able to build a shelter. You need to look around at mines, caves, subways, subway stations, and deep underground parking garages. You're going to get a protection factor of 1,000, even 10,000 in those deeper layers. So that would be a good place to go if it's not a blast target. I don't want to be caught in there if there's blast, because they certainly won't survive blast. But for a fallout area, if you have your 72-hour kit and you have to go someplace and you know where you're going, then these areas would be good. Hospitals have underground tunnels that go from they'll have one building to another building, and they're all underground. You get a lot of good protection in those tunnels. So if any of you are medical workers, then you might think that's where I'm going to go. I'm just going to pick up everything in the family and go into those tunnels. Pipe chases in those big buildings as well. Basements of large structures. And when I say large structures, I mean multi-level structures. The first 3 stories of buildings will give us between 20 and 80 protection factor. And if it's more than 10 stories, you know, you can get some really good protection. I don't know, there it is. So you can see this basement that's kind of partially above ground, just a little below ground, you only get a protection factor of about 2. But 2, you know, if you're a long ways away, like I am, even 2 is going to help. And if I didn't get to my shelter, but in my home per se, you get a little more when you're getting down a little further. If you have a basement with 1 story, 10 to 250. And when you're looking at 250, you're in the center, you're away from windows, you've covered your windows. You may have to add a little more shielding overhead with a heavy table or something where you're putting books and things overhead. These tall buildings, they're going to give you some better shielding here, 250 in here, because this gets the shielding from here, and this is shielded from the ground. And of course, these would have a fallout on the first 2 or on the ceiling that would affect the first 2 or 3 levels. But once you get into this middle level, you're going to have much more protection. And same here, you get a protection factor of 1,000 in these high-rise buildings in the middle of those buildings, or deep below in a double deep basements. You could get a lot of good area. So when we're building, I'm going over my time now, that fallout shelters are very similar to the blast shelters that we talked about. And we are seeing that these are based on 15 PSI and 45 PSI, but they're still telling you that 16 inches of concrete right here in a 1-story building, 16 inches of concrete, you get a doubling every 3 inches. So you're going to have more than 5 doublings on that, plus your roof and the distance from the ceiling to the roof. So you're going to have 5 doublings. You have 2, 4, 8, 16, 32. So you'd have a decent protection factor of 32, plus what this ceiling is going to give you and this roof. So you probably could, you know, maybe even get into 100 here, a protection factor of 100 with the 16 or 18 inches of concrete here. Where if you're outside and above ground, then you have to have some hefty walls, 31 inches here and 22 inches here, 31 inches of concrete, that's 10 doublings, that's protection factor of 1,000 on the sides. But there's nothing above it to protect you. So you have to have, we're protecting from all of the fallout on the ground. And then the D2 level with 22, we're expecting that would blow off and there'd be less radiation here. It would be mostly on the ground. So the war gases, that is a concern. I don't know how much of a risk it is. We have our airlocks, our ventilation systems are run on a positive pressure system. They have filtration with both HEPA and charcoal filters, but get a good ventilation system that has been tested, and you know that all of that air coming in is actually going through that filter. so that you're not going to be getting any of the bad air. So this comes in through a pipe here that goes above grade and then comes into a gooseneck. And so the big fallout falls on the ground, but the gooseneck then doesn't suck up any of the big particles, comes down and gets through the pre-filter and then down through the metering device. The metering device tells us how long that we want that air in the filter. So this just unclamps here and it goes on both sides of the filter, and then it comes back up through here, and the good air, the filtered air, comes here. So we need to be aware of all of this, and it must have electrical and manual function, and it has to have blast valves and steel air vents, and the blast valves are actually a pressure valve. So even if there's not a blast, we want to pressurize the system so there's a slight positive pressure within that system. So I think that is about what we have today, and we've got 5 minutes more, so we could have some more questions if there are any.
The only one I'm seeing here is about for old schools, churches, and et cetera that used to be designated as fallout shelters. If they survive, are they still considered safe? I think someone was mentioning of how many of those have been replaced in a lot of places.
Yeah, well, and again, anything that's going to be below ground, and hopefully it won't catch on fire with long runs of wire, but anything that has a basement and has a good structure overhead and it's high, the higher it is, the better it is, because you get the distance advantage. But center parts of those large buildings are still good. You're going to get a protection factor of maybe 10 or 15, but look and see what you think you'll be getting, and is a protection factor of 10 or 15 good enough? You know, if we were looking back here at our, if we can go back to the medium, that was high fallout. Well, a protection factor of 15 isn't going to do you much good here, because you know you're still going to get a 1,500 rads, which is way too much. But if you're maybe in 20, 750 rads, or if you're in high fallout, that probably not going to save you, but it's better than nothing. It's and in medium fallout, protection factor of 15. You get 150 to 300. That's still not quite enough, but in low fallout areas, it would be, and maybe, you know, in lower places, it could be a factor of 20, but it's better than nothing. You want to do the best you can with what you have.
Exactly. I'm not seeing many. Let's see. Yeah, I'm not seeing many other questions. I mean, I can chime in with the EMP thing. I've looked into a little
Okay.
bit. For at least as far as companies, there's a lot of snake oil out there of things where it's like, hey, hook this up to your car, or hey, hook this up to your house, and now you're 100% protected. And it's like, not sure. I don't know what kind of black magic they're infusing these devices with, but I'm pretty sure that's not how it works.
Well,
Um, the
it's
ones at least I've noticed, the ones that I use personally, this is not official, not official TACDA sponsored, by the way. Just putting that out there. These are the ones that I use personally, which is Mission Darkness, simply because they have test results um, published. So that's just the ones personally I use. But for Faraday cages, but it's that whole protection stuff that can get real dicey really fast, as you had mentioned, of just needing.
it shouldn't be that difficult. You know, if we're totally surrounded by metal, if we have a door on it that doesn't have a rubber gasket, it's metal to metal. We've sanded off any of the paint around it, and it's a good metal to metal contact, then it's a decent Faraday cage.
Yep,
But
just being meticulous, getting all those little details.
yeah, and so our radios, we've talked about radios before. I put my ham radios in a good metal garbage can, and I do provide insulation on the sides for it. But before I put the lid on, I wrap around the top of that metal can with wire, with metal metal screen, and fold it over the top of that lid around the rim of that can before I push the lid on, so I have metal to metal. Otherwise, you get a slot antenna effect because EMP will get in the tiniest holes. So we need to protect our radios and our small little transistor radios with the antenna down, maybe not too vulnerable, but we only have one chance. So we want to protect everything we can.
Exactly. I know for solar, at least, what I found was a research paper saying at least like the panels themselves are surprisingly resistant. It's just when they're plugged into the inverters and the power
Yeah.
banks, that's
And
the stuff.
definitely not, they're not protected. The controllers and the inverters, they're going to have a problem. And so we have to have extra ones in a Faraday cage.
Exactly. I'm not seeing any other questions. So a lot of thank yous from everyone attending to you, Sharon.
Okay,
So
I'm certainly happy to visit with anyone, and we'll put this out again. It's been recorded, so you can study it if you want to.
yeah, thank you so much. And thank you everybody for joining. It was our pleasure. Hope everyone has a fantastic rest of their evening or morning, whatever time zone you are currently in.